Alright, the last presentation in this fifth module is going to be about access lists and how we apply access lists. Now, there are a few basic things you need to know about access lists. Basically, they're also called access control lists, or ACLs, and they're used to identify traffic based on specific features. Access lists, by themselves, do not do anything other than identify traffic. Until they're applied, they are completely meaningless. And so access lists are analyzed in list order. In other words, the first entry to match is the first entry that applies, and access lists that do not have, basically, if traffic goes through the access list and no entry is matched, then traffic is denied implicitly. This is a feature of access lists that we refer to as implicit deny. And so you have to be very, very careful when you write your access list rules whether or not you would like to implicitly deny traffic at the end. A very common mistake I see is that engineers will remove a number of lines, or possibly all lines of an access list, while leaving it applied in some way. And what will happen is this will cause the access list will not match anything, but the implicit deny at the end will still kick in, and it will deny all traffic. Access lists are used in several different ways, but they're used mostly for firewalling, but not just for that. They're also used for other things. So there are a few different types of access lists. We're going to talk about two, but you need to know about all of them for the CCNA exam. The first one is a standard access list. With standard access list, you only specify the source IP address. With extended access list, you can specify a source and a destination, and you can specify an IP address and a port, possibly a protocol, and a number of other things. There are also reflexive access lists, which are used to identify a first packet and then allow the rest of the flow. This is really nice for servers, for example. When somebody initiates a connection to the server, you want to make sure that you're not just allowing everybody to connect to the server at the same time, but that you're only allowing that host to connect to the server and not allowing anybody else. So dynamic access lists, which actually require you to log in before the access lists take effect. There are also time-based access lists, which apply at different times of the day. We're only going to discuss the first two, but you should know about the other type. So before we talk about these access list types, I actually want to take a quick detour and talk about wildcard masks. Now, wildcard masks are used to determine what portion is important and what portion is unimportant. And the difference in a wildcard mask is that the relevant portions is marked with zeros and the irrelevant portion is marked in ones. And from that perspective, it's actually more of a bitwise knot of a subnet mask, because typically when you write a subnet mask, you consider the network portion as the important thing, and so you put the ones in the network portion. Well, with a wildcard mask, we want to put the ones in the irrelevant portion, which would normally be the host bits. And so wildcard masks can also be used for other interesting things. For example, you could specify even or odd hosts on the network. You could specify hosts that only 32 in the second octet and ignore all of the other octets. You can do almost anything with wildcard masks because they do not require contiguous ones, unlike a subnet mask that requires a continuous set of ones followed by a continuous set of zeros. In subnet masks, you can put the zeros and ones wherever you want. The important thing about a wildcard mask is that the ones are the unimportant bits that are not matched against anything, and that the zeros are the important bits that are matched against whatever the access list entry is you're writing. So first we'll talk about standard access lists. Standard access list is very simple. The syntax is access list space and then the number of the access list that you're specifying, and then a permit or deny, and then the source address and the wildcard mask if applicable. So the number, or pardon me, yes, wildcard mask. The number must be between 1 and 99 or 1300 and 1999. I've never seen anybody go over more than 100 access lists, I'll be honest. And you'll have to remember these are not individual entries what we're talking about with the numbers. This is the actual access lists themselves. So it's one number per list, and you're going to have multiple numbers. So access list 1 may have several different entries. Access list 2 may have several different entries, and so on. Wildcard masks can be dropped, and you can prepend host instead of using a wildcard mask for individual hosts. This is nice if you have a specific host that you want to identify, and the equivalent wildcard mask is all zeros. That's saying that all of the bits are important. So what you would say is, instead of, as for example, access list 1 permit host 10.1.1.1 would be an example of the use of the host keyword. You can also use the any keyword, and that would just be something as simple as access list 1 deny any, and that would is used to specify any host that applies basically any traffic that comes through the access list. And note that only the source is specified in a standard access list entry. You cannot specify the destination. These are not very CPU intensive because they only look at the source address, and so you can apply these as much as you want pretty much. Now we'll talk about extended access lists. These are the more powerful and probably more commonly used of the two access list types. And you'll look at the syntax for this and probably say, Ryan, what are you doing? There's a lot here, but don't let this mass of parameters overwhelm you. Basically, the format is the same. You're going to have an access list and then a number, and then a permit or deny, followed by the protocol, and then the source, and then the destination. So access lists are typically permit or deny, protocol, source, destination. The access list numbers for extended access lists are between 100 to 199, and there's another higher range. Again, I've fairly rarely seen, in fact, I don't think I've ever seen anybody go over 100 extended access lists, especially. The keywords hosted in still works, so you could specify either the source or destination as a particular host, or you can use the any keyword. There are additional keywords that you can use. Instead of specifying a source port or destination port, you can actually use, for example, for port 80, you can use www. You can, instead of equal, the EQ stands for equal, you can specify that an access list is an entry is equal to a particular port. You can also specify an entry that is not equal to a particular port, or possibly less than, or greater than, or possibly a range of different ports. Deeper packet inspection is required for these sorts of access lists because you're matching ports, you're matching protocols, and so these tend to be a lot more CPU intensive, and if you can avoid applying an extended access list, I highly encourage you. Here are some of the keywords and ports and some common services that you might want to write access lists for. You can see the keyword over there on the far right, and you'll see the www example that I mentioned for HTTP port 80. And there are some other examples here as well. You should actually have most of these. You should know most of these off the top of your head. These are some very common services and their ports and what protocols they use. You don't necessarily need to know the keywords for the CCNA exam, but it's probably not a bad idea. And so for access list management, you can actually display the lines of an existing access list with show IP access list and then the number. Access lists will be displayed in the running config without line numbers, and so this is useful. This command is useful to see what the actual line numbers are for any given access list. Access list entries can be added to the end of an access list in configuration mode and global config mode, but if you want to add a particular entry, if you want to insert an entry into the middle of an access list or remove an entry possibly from an access list, you have to enter access list configuration mode. And so to do this in global config mode, you would specify the access list, for example, IP access list standard 1. And then after that, you would specify the line number, and then possibly or know the line number to remove a line, or you would specify a line number if you want to add it in the middle, and then specify the syntax for the rest of the entry that would follow the syntax that we went over in the previous slides. So again, there's a separate configuration mode if you want to add or remove entries from in the middle of an access list. So now we're going to start talking about the different ways we can apply access lists. Probably the most common way an access list is applied is with an access group. And basically, an access list can be applied to an interface to permit or deny traffic on this interface. As you can imagine, this is very, very commonly implemented with a firewall on a WAN interface. And you can actually permit it or deny it for inbound or outbound traffic. So looking at an example here, you would say interface, for example, let's say we want to apply an access list to fast Ethernet 0/0, you would specify that the access list would be applied with the command IP access group, and then you would specify the access list number that you're interested in, and then in or out to specify whether inbound or outbound traffic should be matched based on that access list. Access class is very similar to access list, only access class is applied to VTY lines, so telnet sessions, SSH sessions. They can be applied inbound to specify who can connect to a particular router or switch. They can also be applied outbound to specify whether or not a particular switch or router can initiate telnet or SSH sessions to other devices. And it's very simple. Under the VTY lines, you would specify access class, followed by the access list number, and then in or out. Some best practices for access lists here. You should apply standard access lists as close to the destination as possible. And basically the reasoning for this is because you only specify the source when you specify a standard access list, and because you don't want to accidentally limit a particular source, you would want to specify it as close to the destination. You want to apply it as close to the destination as possible, so you don't accidentally cut off that source from resources it might need to access. You can apply extended access lists basically wherever you want to, but people encourage you to apply them as close to the source as possible. That way traffic is discarded immediately. It doesn't take up unneeded bandwidth on your network, saves a little bit of time. Some people favor a different version of this rule where you would want to apply extended access lists on the most powerful router on your system, which can also be true depending on your hardware limitations, how many access lists you're applying, and all that good stuff. Before modifying access list, I usually encourage you to make sure that it's not applied anywhere. Again, I've had engineers that will remove an entire access list, and because that may be applied to an interface, if you remove all of the entries in that access list, the implicit deny takes over. And so if you may be connected to, say, the internet doing a WebEx session, and you have an access list applied on that interface, and you remove all of the entries, the implicit deny takes over, the consumer loses their internet connectivity, you lose access to the WebEx session, and it's very, very hard to fix. So I usually advise people, if you're going to mess with an access list, make sure it's not applied anywhere. The alternative, as I mentioned, is to get into the access list configuration mode, and then try to modify it through that. Since access lists are evaluated in order, normally you'll want to place the more specific entries at the beginning of your access list. So for example, your traffic doesn't get discarded by a broader entry at the beginning that you actually may want to allow later on in the access list. You'll probably find it easier to edit access lists in a text editor and then copy the configuration back over to whatever router or switch you're editing. It just tends to save time. It makes it a little bit easier to modify the access list, and that way you don't have to worry about it. You get a chance to basically look it over before you actually apply the configuration. And that just about wraps it up for access list and this 5th module. So again, if you have questions, place them in the comments, and I look forward to seeing you in the next module.